So now is the Q&A session. And so to the audience, please feel free to type your question in the chat box, and you can ask specific question to each speaker, or you can ask general question to all the speakers. And here I find a specific question to Herman. The question is, did you estimate how much the final error is related to the second part, only through feeding the segmentation part with the true phonetic elements, for instance?
Yeah, so I guess the question is, you basically, instead of using discovered phones, you use true phonetic sequences. In the paper, I use it with phonemic sequences. So that's different because it doesn't include variation in words, but that is in the paper. And then also the zero speech baseline systems, there's a top line system which does exactly what you say. And the top line performance, it differs quite a lot between languages, but it can be quite big. So for instance, on I think on French, the top F1 score is 50%, where my best system gets around 25% if word token F1 score. So there's still a very big gap between using discovered units and using ground truth phoneme or phonetic units.
Thank you, Herman. Any question from the audience? Okay, while people are thinking their question, I have one to Danqi, but for other speakers, if you know the answer or any opinion, you're also free to answer. So I have a question to Danqi. Is you propose a contrastive learning approach for sentence representation, and you use dropout instead of other augmentation approach. As you know, in image or speech, we have all kind of augmentation approach proposed. It looks like using dropout is a very general approach. It can be generally used in all kind of modality. So did you see other modality using this idea to do contrastive learning? Do other modality or other paper use dropout to do contrastive learning?
Yeah, thanks for the question. So yeah, I want to emphasize that data augmentation in NLP is actually more difficult compared to like image and the speech, just because language has this discrete nature. So one key point we want to show in the paper is that we actually find all the discrete operations, discrete data augmentations didn't work that well in this contrast learning framework. And we were actually very surprised that using just dropout to do the data augmentation actually works so well. And then in the past few months, we have been also seeing some other work trying to propose like other data augmentation in the continuous space, and it works even better than dropout. So I would say like the using dropout is more equivalent to other like data augmentations in images, but I don't see like exactly the same thing applied to other modalities yet. Yeah.
Thank you, Danqi. We have a question to both Yang and Herman from Xinji. How did you deal with silent short pause? In the HNN era, we try to deal with it differently, different duration model. Do you have any comments? Yes, Yang, you start.
So indeed, silence is tough to model for neural models because they tend to assign several some symbols to it, especially when there is silence with a little bit of noise. So it's on the pragmatic side, it helps to run everything through a VAD first and then swipe it under the carpet. The silence is also challenging because it has high variability in duration. So for instance, when we did this sentence piece clustering, we actually tried to have it repeat symbols, just because otherwise silence would be the longest symbol, and since it doesn't really matter whether you have 20 or 21 frames, but these are technically different things for sentence piece, it would eat up most of the model space. So it is a tiny pain to deal with, and I guess that hacks are needed, but hopefully a general model should be able to handle long pauses and perhaps eat the short pauses, as then we tend not to write them down, so they're not probably crucial for the meaning if we go up into understanding. I don't know, Herman, whether you have something to add to it.
No, I'll just also be honest and say very tight voice activity detection is what I do, but it's just, yeah, everything Jan says is true. And my model is actually really bad in this regard because it has one duration model irrespective of what word or what discovered unit it's in. And so, yeah, it's important to do tight bad.
Okay, any question from the audience? Okay, while people are thinking, I have a question. In Herman's talk, Herman mentioned that we have probably reached the limitation of word segmentation by speech. So I would like to know the opinion from Jan. What do you think? Do you agree with Herman? And Herman, do you have more evidence to support your idea?
I guess that the extra context really helps. So if you look at the zero speech results from the second contest they did, there was the audio-visual track, and this worked really well on a task called SIMI, so finding word similarities. We sort of hoped to get there by word discovery and so on, because we knew that the word2vec on perfect boundaries works really well, but we couldn't match it. So I attributed this to the extra context from vision. And I guess this is a very strong supervision that two things relate to the same concept because they look the same. So some top-down or maybe not fully supervised, but some sorts of supervision, a little bit of supervision will go a very long way. It's also visible in the current way to do this self-supervised ASR when you do basically feature learning or representation learning on vast data sets. And then just a few hours of transcribed speech or even a language model, right, like Favus demonstrated, goes a long way to essentially having a workable ISR system. But it's really hard to remove this dependency on even like a tiny bit of labels.
Yeah, I don't think I have concrete evidence. I think everything that Jan says I agree with. The one thing is, so I think there's two things. One, you can start to quantify this by basically training these segmentation models on ground truth phonetic sequences. So it links with Sala's question, and you can see, you know, how close you get to that. But I think there's just a bigger argument that there is some upper bound where without, well, and this is just a personal belief, there's some level of word segmentation results that you just can't get to without some top-down signal from vision or from something else. And that's just basically what I'm saying is it's not possible to learn word meaning without some external signal, which is the argument I guess a number of people are making. So I don't have concrete evidence, but there is some upper bound, and I'm wondering if we're starting to get there.
Thank you very much for all the answers. Any questions from the audience? Any question from the audience? Okay, I have another question also to Jan and Herman. So for all your experiment, so you use the data set like Libri speech. I missed the data set you use, but have you tried more realistic condition? If the audio have large noise, reverberation, does it largely influence the performance, or those unsupervised learning approach, they are robust to all this kind of errors or noise? So who want to go first? Jan, you left, so probably you want to go.
Well, I laugh because I don't really have a good answer to it, because being sort of limited by the 8 or 4 free GPUs, we never ventured into doing this on a very large scale and very noisy data. So I don't have a good intuition whether things would work really bad when you add noise, or they would somehow magically regularize themselves and improve. I would hope for the second one, but I'm not sure that that this would happen. Maybe Herman has has better experiences with it.
No, I think my intuition matches what you said. I hope for the second one, but I believe that the first will probably happen. I think the one thing is that if you can pre-train on humongous amounts of data, like really enormous data sets, then I think hopefully you'll be able to start to deal with the noise. So all the models I describe is basically taking a huge CPC model that Facebook trained and then operating on that. And hopefully that helps with some noise robustness. But I think if you start to apply the stuff in realistic settings, it's probably going to do a little bit or maybe a lot worse than it's doing now.
The models should probably also model some utterance-wide characteristics. So for the TTS models, there are many models which actually allow you to denoise speech. So they are able to disentangle between the contents and the channel properties or the microphone or the noise. And so the models we were playing with basically don't have this utterance-wide encoding. Probably would also have to somehow stash it into the content one and make a mess. But so the model should be changed also slightly to accommodate it, to split between the noise model, channel, and contents. So I hope that the content part generalizes or survives in this setup.
Okay, so any last question from the audience? Okay, if you have, probably you can raise your hand because we are running out of time. If you have any question, we take the last one. Okay, if not, let's thank all the speakers again. Thanks Danqi, Herman, and Yang. Thank you very much. Thank you. Thank you.
Yes, and thank you for the invitation.
Thank you. Thank you. And we take a 10 minutes break. We'll be back at 11:10. And so see you after 10 minutes. See you later.